Hey everyone! In today's video, we'll be covering descriptive statistics and scatter plots in R. For descriptive statistics, we'll be looking at things such as the mean, the median, and the standard deviation of different variables. And for scatter plots, we'll be using base R functionality, which is just things that are already built into R without the use of any additional packages. And we'll also look at the package ggplot2, which provides a little bit more flexibility in plotting scatter plots, histograms, and other things you might run into the future. So we're going to go ahead and open up RStudio. Okay, so now I have my RStudio open, and what I have here is a template that I've uploaded online. Essentially, these are just a bunch of commented out strings of text that are going to help organize our syntax that we type out. So you can use this one if you'd like, but you can also make one of your own if you want to do that. Okay, so the first thing that we have to do is we have to read in our data set. So for this and the labs moving forward, I will stick with the tab delimited file, but you're welcome to use whichever file that you like. So I'm going to go ahead and create an object that contains our data set here, regdata1, and I'm going to use the read.table function to read in the data set. Again, the first thing we have to do is specify the path and make sure if you're using a PC that you're using forward slashes. In a Mac, I believe that backward slashes work just fine. So my data set is located on my C drive in the datasets folder. If you're having problems locating the file path, just refer to the previous video on reading in data, and there I show how to figure out what this file path is. And what I'm talking about is this right here. So in the C drive and in the datasets folder, that's where my dataset is located, and the dataset name is regdata1, and it's a .dat file, which is a tab delimited file. I have to specify a couple options here, so I want to say that there's a header, so header equals true, because the first row of my data set are the variable names. And then the separator, SEP, equals, in quotes, a backslash and a T for tab. So the separator in my data file is a tab, and this backslash T is how we specify that. Okay. Now that that's done, I should be able to read this in, so I'll go ahead and run it. Now remember, to run this chunk of code, just make sure the blinking cursor right here is on the correct line that you want to run, and then you could just press run here, or I like to use the shortcut Control Enter, so I'm going to go ahead and do that. So I'll hold Control, press Enter, and that will run that one chunk of code right there. Okay. So here, if we look under our environment, we can see that we now have a data set called regdata1. And then if I want to check to see if that has read in correctly, straight into the console, I'll just type in head to see the first 6 rows of this data set. And I want to look at regdata1. Yep, and it looks like that it read in fine. Okay. So now that our data set is in, we can go ahead and move into computing descriptive statistics. So what I'm going to focus on first is computing descriptive statistics for our y variable. So you can see here in the first column we have y, and I want to compute some descriptive statistics for that variable. So I'm going to start with sample size, and the way that we could do that is we could just compute the length of regdata1, and then this is something new, the $, and then y. So when referring to variables, you want to use the name of the variable, which is y, and then you use this $sign to indicate what data set it's coming from. So in any R session, you might be using multiple data sets, so it's important that you specify which data set the variable is coming from, the $sign, and then the variable, so y. So regdata1 $y. And then we're using the length function because that'll tell us how many of that variable we have, which essentially is our sample size. So we can go ahead and run that. And you can see here it's 150, which is the number that it's supposed to be. So our sample size is 150. Now I want to move on and I want to compute the mean, the standard deviation, and the median. So I'll compute the mean, and then again we type in our data set, a $sign, and then the variable. And then the standard deviation, same thing. And then median. So these are all pretty simple. The function names are just the names of the statistics that we want. Okay, so I'm going to go ahead and run these simultaneously, so you could just highlight them. Again, you can press the run variable or the run button here, or you could just press Control Enter. Okay, and then if we look down here at the console, we can see that the mean is negative 0.07, the standard deviation is 0.96, and then the median is negative 0.08. The next descriptives I'm going to compute are the min, the max, and then the range. So again, pretty straightforward. The min is just min, and then the max is just max. And then for the range, I'm actually going to take the max and then I'm going to subtract from it the minimum, and that will give me the range. Okay. So again, I'm going to take these three that we just wrote out and I'm going to run them all together. And here we see our minimum is negative 2.67, our maximum is 2.36, and then the range, which is the maximum minus the minimum, is 5.04. Okay, so that's a lot of typing, and that's all for one variable, which is y. And in our data set, we have 6 variables. We have y, and then we have x1 through x5. So if you want to be able to get through descriptive statistics a little bit more efficiently, we can use something called the describe function. So that is going to be in the package, in the psych package. So if you don't have this package, be sure to install it. You can do that by typing in install.packages, and then in quotes, psych, and then you can go ahead and run that line. I'm going to go ahead and comment this out, and then I'm just going to use the library function to load the psych package. Okay, now that the psych package is loaded, I can go ahead and use the describe function, and the argument that we want to put in the describe function is the object that contains the entire data set. So we're no longer just looking at one variable. We're going to put in the entire data set into this function here. So our data set is reg data 1, and then we can run this line here. And there we go. So for all 6 variables, y, and then x1 through x5, we have our sample sizes, we have our means, our standard deviations, our medians, our trimmed mean, our mad absolute deviation, our minimum, our maximum, our range, and we even have things on the shape of the distribution of the variables. So we have our skew and then our kurtosis. So with skew and kurtosis, values closer to 0 indicate that variables are more closely distributed normally. Just a note here that kurtosis here is actually excess positive kurtosis. So the kurtosis of a normal distribution is equal to 3. But what R does is it takes those values and subtracts 3 from all of them, so that 0 indicates no positive excess kurtosis, which is indicative of a normally distributed variable. So just remember, kurtosis as computed by the describe function is excess positive kurtosis, or you could think of it as kurtosis minus 3. Okay. Now that we have computed our descriptive statistics, I'm going to go ahead and move on to scatter plots. And so first, I'm going to use base R. So this is just the default the default functions in R that are able to produce plots for us. So we don't need to install any additional packages, and we can just get right to plotting. So for a scatter plot, the function we want to use is plot. And the arguments that go into the plot function are the x variable first, and then the y variable. So the way that you want to think about that is whatever is going to be plotted on the horizontal axis goes in first, and then whatever's plotted on the vertical axis goes second. So we'll see this when we plot this. So let's go ahead and plot x1 against y. So we're going to plot reg data 1 x1. That's our x variable, and then reg data 1 y, and that's going to be our y variable. So if we just do this with no options, this is the plot. This is the plot that we're going to get here. And then if you press zoom here, it'll open up a new window so you can get a better look at the plot. Okay. So here we have x1, and then on the vertical axis y, and then we have our scatter plot. As you can see, it prints the data set $x1 and the data set $y, and we may not want that. So the next thing that we'll do is we'll add a title and an axis labels to our plot. So I'm going to go ahead and copy and paste this original plot. Let's see. Okay. And then I'm going to go ahead and add a title and axis labels. So remember, between each argument you want a comma, so I'm going to add a comma here after the y variable, and then I'm going to enter or press enter to return down to the next line, just to keep the syntax clean looking. Okay, so to add a title, we're going to type main equals, and I'm going to title it scatter plot of x, 1, and y. I move to the outside of the quote, another comma, and then I'll press enter again to return to the next line. Now I'm going to do a label for the x-axis. So xlab for x label, and I want it to be x1. Again, another comma, and then another return, and then y label, which is ylab, and I want that to be y. Okay, and then if we go ahead and run this, you can see our scatter plot here has changed a little bit. We now have a title at the top, scatter plot of x1 and y, and then we have y here, x1 here for the x and y labels. Okay. Again, I'm just kind of building here and layering on each scatter plot. So I'm just going to copy and paste here, and then now I'll show you how to change the point character. So in our original plot, we have open circles, and in R, there are a number of different point characters that you can use. I think there's about 20, a little bit over 20. It's really easy. You could just Google point characters in R, and it will give you a list and what the different point characters are. But what I'll show you as an example here, so to change the point character, we're going to do pch equals and then the number. So I'm going to specify number 19 here, and this will give you a closed circle. And as we can see here, now we have closed circles or filled in circles for our points on our scatter plot. Okay. Go ahead and copy and paste this again. And the next option I'm going to show you is how to change the color of the points on the scatter plot. So COL equals, and then my favorite color in R is olive drab. And so I'll go ahead and type that in, and then we'll run this. And then again, you can see that instead of being filled in with the color black, they're now all olive drab. Okay. And then the last thing we'll add to our plot is a regression line. So we haven't talking about formally running regression models yet, but this is something that you'll want to add to your scatter plots later on, and so I'm going to show you how to do it now. And in order to add a regression line, after you plot, or after you create your plot, you're going to use this function called AB line, and then you're going to use the LM function, and then what you want to specify, so the LM function is the function that we're going to be using to estimate regression models later on. But we're going to use this to produce a line for us. And so what we type into the LM function is first the variable that is on the y-axis, so that's going to be reg data 1 y, and then the tilde, which is a little squiggly line. And if you're on your keyboard, that should be toward the top to the left. You'll see it above the little tick mark. And then whatever goes on the x-axis. So just remember, it's a little bit different than how we've been plotting. So when we plot, it's x and then y. Here it's going to be y, tilde, and then x. So just try not to get those mixed up. And then comma to move on to the next argument, and I'm going to return down. And so the color that we want, so we're going to specify the color of the line also. So that COL is equal to, and then I'm going to specify that the regression line be black. Another comma, and then next to the next argument, and then I'm going to change the width of the line. So by default, the width of the line is kind of thin, so I'm going to make it a little bit thicker. So to change that, we use LWD equal, and then I'm going to make it a size of 4. Again, remember, you have to plot your scatter plot first, and then these lines of code come after, and then that will just overlay the regression line onto your scatter plot. So I'm going to go ahead and run this, and there we go. So now we have our scatter plot that we've built up with our axis labels as well as our title. We changed the point character to be filled in. We changed the color of the fill to be olive drab, and then we've added our black regression line here. Okay. And then I'm not going to go too far in depth on ggplot2, but it is something that a lot of people use when they're graphing in R, and it is a little bit more flexible and offers a little bit more variety in terms of options when it comes to making plots. So I'll show you how to recreate the plot that we've just made in ggplot2. So the first thing is, if you don't have the ggplot2 package, be sure to install that. So it's just ggplot2. And then be sure to run that line if you don't have it. I'm going to comment it out. And then I'm going to load the ggplot2 package. Okay, and I'll run that line. And then now what I'm going to do is, in ggplot2, you actually put the plot into an object, kind of like how we've been doing with data sets. So I'm going to create an object called scatter, and then I'll start specifying my plot to put inside that object. So I'm going to use the ggplot function, and first goes the data set, and then we're going to use this AES function. And this describes how the variables are mapped onto the plot. So it's going to be x1 and y. So these are my x and y variables. So what goes on my x-axis and what goes on my y-axis. So AES, through the AES function, we're able to specify what goes on which axis. And then now I'm going to use a plus sign, because I'm going to start layering on to this base plot that we've made here. Okay. Now the next thing I'm going to specify is geom underscore point. Okay, what this specifies is that it's going to be a scatter plot. So there are going to be points on this plot. Then another plus sign, and inside of this geom point, just to note, nothing goes inside there. So it's just open parenthesis, close parenthesis. Okay. Now next is the title, so that's going to be GG title. And in quotes, I'm going to use the same title that we've been using. So scatter plot of x1 and y. Another plus sign, and then I'm going to return. And then next I'm going to specify the theme. So for APA style plots, I think the one that most closely resembles APA style plots are theme classic. And then again, nothing goes into that function. So theme underscore classic. And then the last thing, the last two things, the first one is I'm going to make an adjustment to the title. So by default, ggplot will left justify the title, so it will be toward the left. But I want my title to be in the center. So I can specify that with this line of code here. So essentially what we have is we're going to make changes to the theme, and so I want my plot title, I want it to be adjusted horizontally by 0.5. And what that will do is it will center our plot title. And then the last thing here is I'm going to add the regression line using stat smooth. So it's stat underscore smooth. So the method is going to be in quotes lm, similar to the lm function that we've been using, or the lm function that we use in the plot or in the AB line function for our plot earlier. The formula, so we need to specify the formula here. So the formula equals, again, it's going to be y and then tilde x. And that should be a lowercase x. So this is really important, but this y tilde x, these are not the variable names that are in the data set. It is actually just specifying that there's a y variable, a general y variable that is predicted from a general x variable. So you could just leave it exactly like this, and you don't have to change this little bit of code to match your variable names. So just keep it like that and don't change anything. The next thing we're going to do is specify that we want SE, or standard error, to be false. So by default, when adding a regression line, it will add, we'll talk more about standard errors later, but it will add this shaded area around the line to show, to reflect the standard errors. And we don't want that, so we'll say false. And the last thing is to specify the color. So COL is equal to, and then we'll make this regression line red. Okay, so if we go ahead and just run that, it'll produce our scatter plot, and it's in this object called scatter, but it won't print it yet. So to print it, you can just type scatter by itself, and then you can just run this line. And here's our plot. So again, this is very similar to the plot that we had earlier. It's just using a different package, ggplot2, and later on, as you start to plot things that are a little bit more complex, ggplot2 does offer a little bit more flexibility. So, for instance, if we want to plot, our data, a scatter plot of our data, and we don't want a straight line, but we want a line that has a bend in it, It's really hard to do that just using the plot function in base R, but it's really easy to do it when using ggplot too. So just something to keep in mind. All right, and so that's it for this video. And with that, that concludes this video on descriptive statistics and scatter plots in R.